In this class, we're going to take a look at how you add and subtract surds, or you might call them radicals. A surd or a radical is just a number with a root that you cannot basically simplify any further. So like root 2, root 3, root 5, so like all those prime numbers. And what we're going to learn to do in this class is take two of those types of number, or it could be more than two, and then add them together, or subtract them. So basically combine them. Before we get to that though, we need to consider the scenario of how we simplify numbers that have got square roots, because sometimes when we are presented with these questions, for example these guys here, they're not in a fully simplified surd form, so we need to manipulate those first. So let's start by just thinking about how we simplify these down. So the square root of 8, well, we can write that as the square root of 4 times 2. And then we can split that into two roots, so that's root 4 times root 2. Okay, that's just a process you need to learn. That's just how the rules work for that. And the square root of 4 though is 2, so that just becomes 2 times root 2, which we just write as 2 root 2. So after a bit of experience, you'll probably drop this line, and in fact you might even, once you've worked a few of these, just go straight from there to there. So that's basically the process of breaking those down. So it doesn't matter which two numbers you choose to make this number. 8 and 1 is no good because you never use that extreme combination. Here we're not going to use 27 and 1. You can use any two numbers in between that you like. This one only really had the choice 4 and 2. Some numbers will have more than one choice. It doesn't matter which ones you choose, but ideally you're looking for a square number. That's one that's got a square root and a prime number. So 27, I think the only choice really for that one would be a 9 and a 3. So I'm going to skip this line this time and just go straight to root 9, root 3. Try and get in the habit of putting the square number first. That's just because we're then going to take the square root of that. So square root of 9 is 3, and we just get 3 root 3. So try to be quite efficient with these. They shouldn't really take a whole lot of work in. It's just identifying those key numbers. Once you've done enough of these, you'll see a lot of the same numbers over and over, and you'll probably just start to learn some of the answers. You'll just know that root 27 is 3 root 3 after you've seen them a few times. Okay, let's have a look at root 20. So 20 could be 10 and 2, could be 5 and 4. 10 and 2, 2 is a prime number, 10 is not a square number, so that's not an ideal combination. 5 is a prime number and 4 is a square number, so that's a better combination. So we'll go for that one. So root 4, root 5. Square root of 4 is 2, so we just get 2 root 5. Just to demonstrate, if we did go the other way, if we did make that root 10, root 2, we'll still get there eventually. It's just going to take a little more work. So the square root of 10 we can break down again. We can make that root 5, root 2. So that bit there is just for the root 10. We've still got the other root 2 on the end like this. Root 2 times root 2 is root 2 squared, but root 2 squared, so square root of 2 squared, the squared and the square root just cancel, and that just comes out to be 2. So these guys just times together to give you 2, or you could think of it as root 2 times root 2 giving you root 4, and the square root of 4 is 2. Either way, the square root of 2 times the square root of 2 is 2, so that's going to be root 5 times 2, which we would just compact as 2 root 5. So it just gives us the same answer anyway. Notice though how much more working we had to do there. We had to go through all of this pain just to get to 2 root 5, whereas here we just went straight almost to it. That is the beauty of getting this correct combination, so a square number and a prime number. So these questions are usually designed so that you will find that combination quite quickly, but it does take a little experience to get to that point. So that's just how we simplify surds. We're not at this point actually adding them or subtracting them, we're just kind of prepping for getting to that point. Really important technique though, if you're going to be working with surds or radicals you might call them, then this is really, really important because you're going to be using this kind of technique all the time. Okay, so coming over here and we're going to think about how we combine them. So here we've got root 7 plus root 7. So all we need to do there is basically add up how many root 7s we've got. Remember that there's kind of secretly a 1 in front of these, so it's 1 root 7 plus another root 7. So if you've got one of anything plus another, you've got two of them. So basically we just get 2 root 7. The big mistake in this question is to write the answer, or what we think the answer might be, as root 14 by adding the two 7s together, but that's not correct. That's an overcomplication. You're just adding up how many root 7s you've got. Similarly here, we've got 3 root 5s, we're adding 4 root 5s. Well, you've got 3 of them, you're adding 4 of them, so that's just going to give you 7 of them. So you've got 7 root 5s. So in these two examples, we were able to add the surds, the radicals, directly. So there was no manipulation required. This was a root 7, that was a root 7, so we added them. These were root 5s, they were root 5, so we just added them. This one's slightly different though, because we don't have the same type of surd. That means that we've got to manipulate them, because we can only add or subtract like terms, just the same as with algebra. So we can only add these or subtract them in this case if we can get them into the same form. So what we're going to do, we're going to pull in the technique that we tried over here. So the root 8 we've already got is 2 root 2. So let's just maybe rewrite this. So it's going to be something minus 2 root 2, which is another way of writing the root 8. That means that if we want a number here to represent the root 18, which we can then subtract this number from, it needs to also be in terms of root 2's, because they need to be the same type of surd. So we're just going to do what we did over here with the root 18, which is going to give us root 9 root 2, just breaking that number down. Square number, prime number, not only a prime number, but the same prime number as we had here. So we get 3 root 2 minus 2 root 2. 3 root 2, take away 2 root 2 just leaves you with 1 root 2, which we would normally just write as root 2. And that's the final answer. So usually with these questions where you're combining surds, you're going to have to do this to get them in the correct same format, the same type of surd before you can combine them. So there is a few skills going on here. This part does take a little experience. Once you've learned to do this, you can then apply it over here. And if you've got these more simple forms, then you can just add or subtract them directly. Surds, radicals are quite an important topic. They come up in a whole bunch of different question types. So I would say spend some time working on this technique. Get it to the point where you're really comfortable with it, where you can just kind of do it as second nature. So check out some practice questions on this topic.